Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 11 of our May LeetCode challenge, and the problem that's been given to us today is the flood fill problem. Again, if you want to try solving this problem on your own, you can pause this video and check out the LeetCode link given in the description below, and let's get started. So this problem is actually a really famous problem and has been asked a lot in Microsoft and Amazon interviews. The problem description itself is actually pretty straightforward, so I won't go through that. If you want to look at the problem description, you can pause this video and check it out on your own. But an intuitive way of understanding how this algorithm works is by actually looking at a real world scenario. So let's take this entire page itself, and let's say that this page I'm sort of hovering over the header, which is black in color. Now the flood fill algorithm works in a perspective of spreading across everything else. And by what I mean by that is that if I select the color white and I say, hey, I want to click on this pixel over here, what's going to do is it's going to update everything which is in the neighboring color and just update it with white. So if I click white over here, so this pixel is going to look at whatever's on the left, the right, the top, and the bottom, and it's going to spread across in all those four directions and try to assign the new colors to them. So in essence, what's going to happen is that everything is going to be white. So that's the entire flood fill algorithm, and it's pretty straightforward. Um, I like the way that you can actually perceive this problem as a real world scenario, and this is actually one of the algorithms which is used for your MS Paint and all that stuff as well, because the boundary condition and all the colors that you're setting is sort of defined by that algorithm itself. So let's get started. So we're going to start with a base condition, which is just going to be if nothing's been given to us, then what we're going to do is we're just going to turn a simple list. Now, I want to help you evaluate like what all is being returned. So, what all is actually being passed rather. So we have an image which is a 2D matrix, a starting row and a starting column, which is the pixel that we're going to be selecting, and a new color that we want to set it at. Our breakaway condition is going to be based on whenever we have something which is not the same color, that's a breakaway condition. So let's say I select this pixel over here, and when I move on my right, I'm going to encounter this yellowish color eventually. When that happens, I don't want to set that color, so that's one of my breakaway conditions. And obviously, I'll have like base conditions where I don't want to exceed the bounds. And as I'm sort of talking about, you can already sort of perceive that this problem is going to solve by using the DFS algorithm. And that's pretty straightforward because you're spreading all across the four directions. So let's just go ahead and make a simple variable, which is going to have directions inside, which is just going to help us go from up, um, down. I mean, this is going to be up, this is going to be down, left and right. So this is going to help us go on our right. Oops, sorry. So this should be 0, comma 1 and 0, comma minus 1. So basically, we're doing bottom, top, right, and left. So when we have this direction offsets, we can use those later. And since you know that whenever you do DFS, it's a safe practice to actually have a is safe method, and that's something we're going to be making out. So we're just going to pass in ing over there, and we're just going to check whether ing are actually exceeding the bounds that are given. So we can say, hey, if I is greater than or equal to length of image, which is the length of rows, or j is less than 0, or j is greater than or equal to the length of image of 0, which is the number of columns. In that case, you want to return false, which means that it's exceeding the bounds. Otherwise, you return a true, which means that it's not satisfying any of those conditions, and you're good to go. We're also going to have a util function, and we'll sort of define that in a minute. But eventually, what we want to do is our entire setup should return the image. So we have return image, and that just gets returned, and we're going to pass in util. So our expectation is that the image is going to be updated accordingly. I do notice over here that I'm not maintaining a visitor dictionary. The reason why I don't really need that is because intuitively you have the image being updated, so that's going to serve the purpose of the visited as well. In the util, what you want to do is you want to maintain the ith and the jth values. So the starting point is going to be SR and SC. So that's going to be your I and your J. And we need a color as well. So let's just go ahead and set a color. So we're just going to say color is going to be whatever's the color of the first of the starting point. So that's going to be SR and SC. We do need to make put a condition in which is just going to say, hey, if color is equal to new color, well, in that case, we don't really need to do anything. We can just return the image. That's just in case, like if I already have black and I'm returning black, then I don't really need to go through a DFS approach. So that's one of the other base conditions that we need to take care of. But that sort of sets us up well in you know, implementing the solution. So the first thing that we're going to do is we're just going to like check whether the values that have been given to us, the I and the j, are actually safe or not. So we can just do, hey, if not is safe I comma j, then you return the value, which is just breaking away from the implementation or the recursive calls. Then the other condition that you want to check is that if image I and j is not equal to the color, so basically the new value that represents the on is not actually the same as the color, which is it's yellow or something like that. In that case also you don't want to do anything. And eventually what you want to do is you want to say image ij is equal to new color, which is the new color which has been passed in. And now what we're going to do is, since this is a DFS implementation, we're just going to say, hey, whatever directions that I have, just use those offsets and update my I and my j. So we're just going to do a quick tuple unpack. We're just going to say for di and dj in directions, which are the offsets that we have. All we need to do is we just have to call the util function. So we just say di plus I, or rather let's do it like I plus di and j plus dj. So this will allow us to go from whichever pixel we started from, we'll get to go on the top, on the bottom, on the left, and on the right. And eventually what it's going to do is going to keep on setting the colors like accordingly, and then we don't really have to do anything, and we just have to return the image. I think that's like pretty straightforward. So let's just go ahead and submit this code, and hopefully this should get submitted. Hopefully there should not be any problems, and you can see that's been accepted as well. So this is a fairly decent problem. It has its quirks, but overall it's a pretty straightforward problem when you know that it's going to be solved by DFS. Cool. So if there's something you didn't understand, or if there are any comments that you have, do leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here, and we would love to have you on board with us. And if you've already subscribed to our channel, you're awesome. We all know it, and have an awesome day. Thank you.